Hi, I'm Jeff, and it's nice to meet you on this virtual day. Today's session is about Smart LV/MV. It's the term we use for smart panel solutions. Because of the time limitation today, I will be giving an overall explanation. If you need more details of the devices and solution, please visit our homepage and send us emails to our contact information. Today's session is the overview of LS Electric's Smart LV/MV, the reason you need smart panels, the system configuration, key advantages, and the application cases. In recent years, we became familiarized with an industry trend called digital transformation, which is a movement to digitalize systems. The electricity supply and distribution sector that supplies electricity to customers is no exception. Key industries like device plants, data centers, manufacturing plants, and large hospitals are demanding more than just electrical system protection. Customers in these industries are requiring protection of equipment, efficiency in operation and equipment management, quarterly management of LV, MV, and distribution panel for greater energy savings and management. Today, I would like to talk about the Smart LV/MV panel that is at the center of this trend. Conventional LV, MV, and distribution panel systems are configured simply with breakers, relays, instruments, and SCADA to monitor and protect the electricity distribution system from accidents. However, the future's Smart LV/MV panels will be different. Protecting the system will just be one of its key functions. They will consist of smart equipment for generating digital data, a communication model that can collect and transmit digital data, and an HMI unit that displays and analyzes digital data as well as mobile and host systems. The Smart LV/MV system from LS is a solution which integrates IoT-based power devices into conventional LV/MV panels and combines this hardware with digital technology that uses the data generated by these devices. The system improves the safety, convenience, and efficiency of managing electric power and energy. It will serve as the foundation for the digital transformation services in the future. The greatest obstacle to the adoption of Smart LV/MV panels is the cost. Because smart equipment is more expensive than conventional equipment, thereby higher initial investment is inevitable when compared to deploying conventional panels. However, the main reason people think of smart systems as an expensive solution with no special options is because it's not being used properly. If a smart system, such as Smart LV/MV panel, is used appropriately, with the increased number of functions, the smart system can be more economical than conventional systems. As you see, it is shown in the graph in the middle. To explain further, the picture on the left shows a conventional LV/MV panel system configuration. As customers need functions such as system monitoring and accident analysis, the system collects data on the current status, accidents, and energy from lower-level devices such as relays, instruments, and breakers using relay devices like PLC. The data is then sent through hard wirings to SCADA. However, smart systems must be able to provide more functions besides the system monitoring and accident analysis functions provided by the conventional system. For example, smart systems must be also capable of failure prediction analysis, alarm, and energy prediction and management. The expanded functions mean that the system must fetch a large amount of data from devices, which is difficult to be done quickly with conventional LV/MV panels. Thus, we have to use wireless communications, and that is why lower-level devices must also be smart devices equipped with IoT technology. In conclusion, I would like to assert that the more functions you have, the more data you must handle. Furthermore, with a higher number of devices connected to the system, a smart system will be more economical than a conventional system. The smart LV/MV system divides into three areas: product, system, and service. The product area of the system consists of smart devices with IoT functions and sensors attached to conventional equipment. These devices and sensors generate large amounts of digital data in real time. The data is then transmitted to the system area following a pre-selected communication protocol. The system area consists of the smart HMI and the local operating system. These are necessary for real-time monitoring, alarm, and reporting of the digital data collected by the smart devices in the endpoint field. In the service area, the digital data from the product and system areas are analyzed. Then the results are utilized for services provided to the customers through mobile and cloud. These customer services could include electric power facility management services like lifespan prediction, energy reduction services, and energy management services for improving efficiencies. Next, I will explain the smart LV panel configuration and devices. First, in the product area, digital data is generated by sensors and smart devices such as smart ACB, smart MCCB, MCB E-Tag, M-Link, thermal imaging camera, IR temperature sensor, and bus bar temperature sensors. Second, in the system area, the LV devices operating data such as panel, HMI, and smart LV can be monitored in real time. The data can be displayed, alarms can be managed, and the data can be reported. Third, the service area provides services including the management of the smart LV electric power equipment, coordination of the other systems, and cloud and mobile services. Next, I will explain the smart MV panel configuration and key devices. First, in the product area, digital data is generated by sensors and smart devices such as intelligent VCB, IED, arc protection, thermal imaging camera, IR temperature sensor, and bus bar temperature sensors. Second, in the system area, the MV devices operating data, including panel HMI and smart LV operating software, can be monitored in real time. The data can be displayed, alarms can be managed, and the data can be reported. Third, the service area provides services such as smart MV electric power equipment management, coordination with SCADA, and cloud and mobile services. Next, I would like to propose the value that smart LV/MV can provide to customers. The customer values towards smart LV/MV could be described mainly as reliability, convenience, and efficiency. Reliability is the value of maximizing electric power availability, preventing electric power equipment accidents, reducing losses, and protecting casualties from such accidents. Solutions to improve reliability divides into two groups. In the first group, we have predictive maintenance solutions, which perform real-time monitoring to predict likely failures and avert them through pre-maintenance work. In the second group, we have solutions minimizing repair times and recovering the system in the event of failure. Due to time constraints, I cannot cover all the individual solutions, but the solutions shown on the screen here are some of the commonly used reliability solutions. For predictive maintenance, we have solutions such as real-time temperature monitoring inside booth bars and panels, power quality and harmonic monitoring, and breaker life diagnosis and forecasting solutions. To minimize repair time, we have solutions including critical event analysis and waveform recording, alarm service through mobile phones when an event occurs, and an arc fault damage minimization solution. The distinctive feature of these solutions is that it is configured with both hardware and software, as you can see on the screen. As mentioned earlier, LS Electric's Smart LV/MV takes data measurements and provides different data utilization methods. thereby consistently striving to bring value to our customers. The second value is convenience. Solutions to improve convenience divides into two groups. In the first group, we have solutions to reduce engineering work, and in the second group, we have solutions to increase maintenance convenience. To reduce engineering work, we have an auto-discovery and auto-time sync solution, which automatically searches for devices and networks and synchronizes them. An HMI and software solution that can be used with machine settings without the need for a separate control menu structure, and a solution where the users can remotely control all power electric settings at the same time. To increase maintenance and repair convenience, we have a solution which allows users to conduct local and remote monitoring of all devices in the electric power system. A mobile solution users can use to monitor the data from devices using the Bluetooth or NFC functions on their smartphones, and a function users can use to upgrade the firmware in devices while driving. Through these solutions, with the systems becoming more complex each year, they can be managed conveniently and effectively and reduce the associated cost. Finally, we have solutions to reduce energy usage and improve energy efficiency. The basic functions provided by Smart LV/MV are energy monitoring and visualization. Needless to say, that energy is not reduced just by monitoring. What Smart LV/MV can offer is efficient and intuitive energy data visualization. Administrators will be able to use it to determine how much energy is being used that day, where it is being wasted, and how efficiently it is being used. The administrator can save energy by checking the visualized data, recognizing the problem, and then reasonably rectifying the problem. Energy reduction starts with visualizing energy data. Without the ability to check, there can be no reductions. For efficiency, we have the following solutions. A solution to monitor and manage energy, power factor and harmonics, and MV panel to endpoint distribution panels. A solution with which users can proactively manage peak power by automatically controlling all breakers in the system remotely. A solution that provides diverse analysis report on energy. A solution for actively managing energy by predicting future energy demand. And a solution for diagnosing electric power equipment like transformers, inverters, and ESS, where efficiency can be a critical factor. Lastly, I would like to talk about some of the Smart LV/MV example cases deployed in the field. The best example is the 6 Smart LV panel units which were installed in LS Electric's Cheongju Factory 1 in April of 2020, installed together with the FIMS station. The Cheongju Factory 1 was selected as FIMS station demonstration site for energy production, energy storage, energy use, and facility protection. Next, a few things to point out about the configuration. To protect electric power equipment such as solar PCU, ESS PCS, and breakers, we deployed the Smart LV solution in Cheongju Factory. Also, the LV operating system connects to the FIMS. This shows what the Smart LV operation system computer screen looks like. The dashboard displays energy and demand management information. The system can also show trends for THD management. The monitoring screen displays a system overview and the device conditions. The last screenshot on the bottom right is the alarm list screen. All these screenshots can produce a report. The final example of our Smart LV operating system screenshots shows detailed information of each device. Taking Smart MCCB as an example, this screen shows the information of a device's electricity consumption rate, their conditions, and lifespan related to information, such as the amount of wear at contact points. It also shows the information on the electric power quality, such as voltage, current harmonics, and imbalance. Shown in the details are the trip generation time, type, location, and trip size. Most recently, we completed installations at an engineering department of South Korea's major university, the Yongsun IDC of K Group and the IDC of D Group. And we are gradually expanding site installations of our smart LV/MV panels. Now we've reached the end of my presentation on the smart LV/MV made by LS Electric. Thank you for your time.